Ladies and gentlemen, what we're asked to do is to determine whether or not this triangle is scalene, isosceles, or equilateral. Now the difference between each of these three triangles is how many of their sides are congruent or the same in length, okay? Now right off the bat, you might be saying, hey, it looks isosceles. If it's isosceles, we know that two segments are the same length. Can somebody name for me those segments? Right off the bat, just assuming that it is isosceles. What could we say? Is AB congruent? Is it in fact congruent to what other segment? BC, good. If this is true, then we know, hey, it's isosceles, right? Let's prove them congruent. Let's find the distance between A and B, and then from B to C. All right, I'm going to let this be length AB. This is segment AB, and this is going to be segment BC. Okay? Ladies? Okay, we're going to go up by how many units? In fact, I'll do this in a different color. To go from A to B, you're going to go up 1, 2, 3 units, and then 4 to the right. 1, 2, 3, 4 to the right. Okay? I'm working through a problem. All I want you to do is just pay attention, and then we're going to go back to problem number 1. Okay? Guys, pay close attention. What we're doing here. This is 3 and this is 4. The distance formula states that the length A to B is going to equal the square root of this number squared plus this number squared. Okay? This number 3 squared plus this number 4 squared. Let's go ahead and evaluate this. Folks, what's 3 squared? Well, 3 squared is just 9, right? 3 squared, we can use a perfect squares chart, is 9. What is 4 squared? 4 squared is just 16. Okay? 9 plus 16 is 25. So now what we're going to evaluate is the sum of these two, that's 25. And the square root of 25, one number multiplies by itself to equal 25. You can evaluate this in your calculators if you're unsure. Yeah, this is equal exactly to 5. Because 5 times 5 equals 25. You could also write this in expanded form. 5 times 5 equals 25. Therefore, the square root of 5 squared is 5. Okay? In BC, to go from B to C, where do we go? We're going to go 1, 2, 3 units to the right. And we're going to go 1, 2, 3, 4 units down. Okay, so we go 3 to the right and 4 down. And you're going to find out that this expression is going to is identical, right, when we write the distance formula for segment length BC. So let's do it again for BC. The distance from B to C is going to equal the square root of this number squared plus this number squared. This number is 3. This number is 4. Folks, isn't this expression the same as this one? Aren't these the same? Yeah, and so all the math is, the ensuing math is going to be exactly the same. If you evaluate this, you're going to get 5 as well. And so going back to our hypothesis that AB was congruent to BC, this is true, right? We proved this true because the distance formula said, yeah, the distance from A to B is 5, as is the distance from B to C. They're both 5. And this is the definition of an isosceles triangle. A triangle